Hello, welcome to the first episode of Hacking Hubs. I'm Greg, and I'm going to try to dive in here. So this is my first time streaming on Twitch, and so I apologize if I hit any weird problems. It's a little bit of a janky setup, as you might be able to tell if any of you are Twitch streamers. So, but just getting started. So today I'm going to be going over a bug that we have seen in Hubs that kind of has been plaguing us for a while. And I'm going to use that as a kickoff point to basically go over some of the ways that our internal Reticulum server works. But certainly if there are questions or things I can speak to, just pop them in the chat and I'll try to dive into those as well. So let's get right to it. So this is the bug that we've had. And so basically, the problem is that we have this concept of pinning in Hubs, and what it is when you put an object in the room, usually the way it works is the object will just go away if you leave. But pinning, what it does is when you pin an object, it ends up saving it to our database. And so, so this is a situation where we actually store data that users are putting in their rooms. And so it's quite scary when anything might go wrong, where the data could get lost. And so for a long time now, we've been seeing problems where somebody will have an object in the room and they'll pin it, and then mysteriously 2 weeks later, they'll come back and the object will be gone. And so this is quite concerning, to say the least. And so I actually ended up figuring out what this was. And I'm going to try to go dig into it and show you, and we'll see if we can fix it live on the stream. So, the bug description is that people had a room and they pinned an object, and then they came back later and it actually was gone. And so to start, I'll just kind of do an example, a live example of how the pinning stuff works. And so to start, you can see here I've got Hubs open in the top right corner of your screen. You can also pop to it full screen, so that'll be a little bit easier to see. And then this is my terminal on the left here, where we'll be able to follow along with the code and all of that. And I also have a little drawing tablet too that might be helpful. We'll see if that works. It's a little bit of a ad hoc setup. So, so the first thing to understand about how our system works is the two pieces of code I'm going to be looking at today are our Hubs client, which is written in JavaScript, which is what runs on your computer when you are using the product. And then in addition to that, the backend service, Reticulum, which is written in Elixir. Yeah, I wasn't sure if they would get too salty here on the stream, and so I figured I might as well mark it as mature audiences to start, but we'll see how I do. It can be a little frustrating debugging software, so I didn't want to have any kids in the room if perhaps I did get a little frustrated. So anyhow, we have two pieces of code I'm going to be looking at. The first is this Hubs client code, which some may be familiar with if you've been hacking on the client, and I'm going to be spending most of my time in the Reticulum backend server. So let's take a look at that. So the first thing I'll do is I'm using, by the way, on the left here, I'm using a Linux terminal. I'll be using a program called tmux to switch between the various things. So you can kind of tell what tab I'm on by looking at, yeah, you can probably see my cursor. You can tell what tab I'm on by looking at the bottom there. Most likely I'll be just using two tabs. The first will be the JavaScript code. So if you go and I pull up our hub.js file, this is our kind of main entry point to the Hubs rooms. And then tab 2 will be Reticulum, which is our Elixir backend. And so I apologize if you're not familiar with Elixir or JavaScript for that matter. I'll do my best to kind of talk through things at a high level as well as in the weeds, so that anyone watching that may not know the programming language involved will at least be able to follow along. So basically the first thing is we will start the server up so that we can actually start working on it. And so we have a little script that we wrote in our repository that is used for starting the server if you are, the password right here. It's for starting the server if you're working on Hubs infrastructure at Mozilla. And so all this does is it just decrypts some secrets so that when we're working locally, it will basically connect to our backend dev servers correctly so that we can actually integration test things against our backend servers. And sorry, I'm just reading the chat as well. This is a new skill for me, so I apologize. So that starts up our Reticulum backend, but of course now we also need the client to run. And so we recently had some changes that make this a bit easier. So npm run local will start the client in Webpack but then configure it so that it is actually talking to our local Reticulum server on our computer. And so that'll start up here. So now if I refresh my page, that'll take a little bit of time while it compiles the JavaScript code, but then eventually will pop in. Yeah, so we're working a lot on getting the dev environment to be a little bit easier to set up. Robert Long actually just made a lot of changes, which are really great in terms of being able to get up and running quickly. We'll continue to try to improve that. The README file is kind of the de facto thing to start with, but certainly we're looking for more ways to improve that. And so one of the things while this is starting up I'll mention is the way our pages get rendered is, I'm actually hitting the Reticulum service right now. And so one thing that I might be able to adjust, well, I'll show you in this screen. You can see my address bar here. I'm actually hitting the Reticulum service on my local machine. So this is a hubs.local that's pointing to my local computer. And then it's on port 4000, which is the Reticulum port. And so one of the somewhat esoteric things that we do is when you hit Reticulum, it's actually going to fetch the JavaScript code and serve it up directly to you. And we do this for a few reasons. One of the most important ones is that if you want your web pages to be able to be curled or unfurled on a site like Twitter or a site like Discord, you need your web server to basically hand back an HTML page that has a bunch of meta tags in the header. And so this is kind of the trick we do to make it so that the server can actually serve up those meta tags if you hit it, but then at the same time use our client code. So Reticulum basically acts as a proxy so that it will add those meta tags. Yeah, so Reticulum, it seems like there's a lot of people asking about this. So a lot of the projects might have very strange names if you're looking through our code repository, and Reticulum is probably one of the less strange ones. So some of the more really strange ones are photognomonic or spielecaptor. Whoops. That one I might not even be able to spell right, it seems. And so these terms actually come from a book called Anathem, which is a Neil Stephenson book. And so throughout the project, we found that a lot of these terms actually are quite suitable for some of the things we created. And so Reticulum so in this book, Neil basically defines a whole new language that is kind of meant to be a language that is spoken by people from another world. And so he invents all these new words that basically have often some direct analog, but often a mixture of English analogs. And Reticulum basically is this language's analog of the internet. It's kind of a global network of interconnected computers. And so for us, Reticulum kind of serves this purpose of being this back-end server that will effectively, hopefully one day, be all interconnected to allow people to meet with each other in virtual reality. And so that's kind of why we did that. And so another term we use in our Hubs Cloud project is polycosm, and that's our internal code name for Hubs Cloud. And in this alternative Arbre universe, polycosm actually is the multiverse, the physics multiverse. And so in this case, we're thinking of this as like the metaverse. And so polycosm basically is the right term for us internally to talk about Hubs Cloud. So anyhow, my Reticulum server now has finally come up. And so I can go ahead and create a room, and we can see that works. Now, this is a really boring room. It has no scenes in the database, any of that. So basically, we're going to just be testing the really raw underlying functionality. So none of these extra things like scenes are really not necessary. So, so if I go into this room, let me just make sure the basic functionality works. And what I'll do is I'll switch back to my console view here, so you can take a look at the data going across the wire. And so as I'm moving around, you can see my Reticulum server is actually receiving all these messages as my avatar moves. And so let's go ahead and just do what we always do on our team, spawn a duck. This is kind of the classic object. If you ever need to test anything with networking, you should always remember to spawn a duck. And so now if I take my duck, I can throw it around. You can see that the networking is happening there. Now if I just leave this duck where it is, if I refresh my page, you'll see that the duck is actually discarded. And usually it's okay to discard your ducks, but sometimes you actually want to keep your ducks. And so you can see there's no duck, right? So let's go ahead and create a duck. So basically, if I have a duck in here, it's kind of an ephemeral duck, if you will. Now if I pin it, as you may have seen, I just pulled up this menu, I hit pin, and now if I come back, my duck is going to still be there. And I bet a lot of people watching have used this, but you might not actually know how it all works. So this duck is just a URL on the internet. And so all we really needed to do was just store the URL along with the information about where the duck is. And so what I'm going to do is I'm going to open up a new tab here, and I'm going to connect to my database. And so here I am. I'm going to be connected to my local database. And so Hubs actually has quite a few tables, but a lot of them are redundant. A lot of them are just partitioned tables. So kind of ignore the stats tables, all of this. The relevant table we're looking for here are, I think it's objects, room objects. And so if I look at the schema for room objects, this is what we store in our database when you pin an object. And so it has a unique ID, this room object ID, and we generate unique primary keys the same way for all the tables in Hubs. It's generally using a scheme to create unique identifiers that was stolen from Instagram for many, many years ago. And these IDs are broken down in a way that if we were to say one day shard our database, we could be sure there'd be no ID collisions. So that's a whole nother thing we could talk about. But that's how the IDs in our database are created. Is used, if you Google for the Instagram primary key sharding method, that's what we do. And then in addition to that, we have this object ID. And this ID, if I recall, is the kind of the networked A-frame identifier. So this is the identifier that ultimately gets used to speak about this object over the network protocol. And so the room object ID is not exposed, but the object ID is the thing that you use to communicate with other users regarding the object. And every object in Hubs, whether or not it's stored in the database, does have an object ID because that's part of the networked A-frame system. And so now we have our Hub ID, which one thing that may be a little bit confusing is we have this term hub in our Reticulum code, and that's really just rooms. We originally started calling rooms hubs, but in the end, we decided to call them rooms when we exposed them to users. But a lot of our internal code still hasn't been updated to reflect it as a room. So anytime you see hub in our Reticulum code, or even in our client code, when it's talking about data structures, you can assume we're talking about rooms there. And so these three keys together basically constitute the information about the ID and what room the object belongs to that has been pinned. Now, the next field is GLTF node, and so that is the GLTF content, which is a JSON data structure that describes the actual object so that it can be rendered and positioned and all that. And so this is the same data structure, by the way, that is used to represent scenes that also are exported from Spoke. And so this is basically just GLTF content. So you could imagine using this pinning feature for other kinds of GLTF content in addition to the objects you pin in the room. But that's what we're using it for today. And so then these are just timestamps of when the object was modified. And then this is an account ID, which is an optional field that will note which account, if the user was signed in, pinned the object. So that's the database schema, and you can find that database schema in our Reticulum code. So the question is, if I select from this this table, you can see that there's all these blobs. And so you just limit oneness. So this is some, so now I can do a /x, and what that'll do is that'll make it a little easier for us to read. And so it looks like a lot like gibberish, but this is in fact our duck. So if I go ahead and say, so you can note that this room object ID, it ends in 4388685. So if I go ahead and unpin this duck, you'll notice that now that's not the last object, the most recent object in the database. We just actually deleted it by unpinning it. So if I go ahead and now pin it again, you'll see now there's a new object again. And if you recall from when it was pinned before, it's BFX. The duck's name actually is BFXFXXR. I dare you to try to say that. If you have a pet duck, this would probably not be a good choice of name for the duck. But nonetheless, that's the name that our computers have chosen for this particular duck. So we're stuck with it. So anyhow, Now you'll notice that the GLTF data is not JSON, which I mentioned, and in fact what it actually is an encrypted JSON blob. So one of the things we've tried to do with hubs is whenever we really can kind of tighten up privacy and security around data, we do. And in this case, by having this encrypted here, it just adds an additional layer of protection, which I don't need to go into all the reasons why, but it basically adds another layer of encryption for this data, which might include, information that might be somewhat sensitive since you're, pinning this object into the room. So that kind of shows you where the data lives. It goes into this database table, and so that's really a higher level thing that is not actually directly related to this bug. It's kind of a secondary thing with this bug. But the thing to understand is that when we pin an object, it does result in a row in our database that is used when you load the room. So that's the first thing you need to understand how we're going to fix this. So now this problem comes up actually specifically when you upload a file. So an easy way to upload a file is to actually just create it. And to create a really quick and easy way to upload a file is to just use like an emoji and then spawn it. And then basically what that does is it will generate this image on your computer, upload it, and then add it to the scene. And so now this is kind of the meat of what I wanted to talk about today, which is how do we store files in our Reticulum server? So I'll try to see if you use my little drawing setup here. Let's see if this works. Oh, no, it looks like it zonked out. Let me see if I can get it to come back. Okay, I'll have that going while in the background here. So this kind of leads me to the kind of storage system that we have in Reticulum. And so I'm going to start pulling up some code. And so we have this storage module, and the storage module is the center of all the APIs we use throughout our backend service for dealing with persistent files that a user may manage. And so so in our storage system, we have this concept of ownership. I'm hoping you can read this. I might need to make it a little bit bigger. Yeah, it looks like the top is cut off a little bit. I apologize for that. Let me make it a little bit bigger. Just one moment. Okay, so so we have this idea of ownership over files. And so when you upload a file, you are the owner. And in fact, sorry, I apologize. When you upload a file, nobody is the owner yet, because what happens is we want to support the ability for people to upload files, but we don't necessarily want to force them to log in to do so. And so we do support the ability to upload files if you're not logged in. However, those files are considered unowned. So they're unowned expiring files. And these files are going to end up on our disk, but they're going to get deleted after 72 hours. And so this is effectively the default path for a file. If a file comes into our server, it's going to go away in 72 hours unless something else happens. And what that something else is it needs to be given ownership. Somebody needs to take ownership over it. One way to think about what ownership means is that once you're an owner to a file, you're effectively the person who will be there to manage it if it were needed to, say, be removed later. Once it becomes an owned file, it will not be removed from our server unless the person who owns it comes and through their login effectively takes actions to remove it. And so, again, a file can be in two states. It can be unowned, which is what happens when it is first created, and then any unowned file will be removed after 72 hours. And then once it becomes an owned file, then it'll be kept on our server. Okay, so I can go into a little bit of the code here. And so this is Elixir for anyone that may not be familiar. And so the kind of, like I mentioned, the flow is that when a file comes in, it's going to end up starting its life as an unowned file. And so you can see basically when we come in, this is the main entry point where we're going to store a file. And let me just jump through here. So this is going to go to store it, and we actually store all of our files encrypted. And so basically, the ultimate result of this is that we end up stream encrypting the data, and we store out a metadata file, which has all the relevant metadata about the file, which right now is its content type, its size, and a promotion token, which I'll talk about soon. And then the file itself is streamed into a blob file, which you can see first it gets the blob file path to store it in here, and then it encrypts it and then writes it to that path. And so the two outputs of storage, the storage system, is the first output is a metadata file that's a JSON encoded file that has the size, the content type, and the promotion token. And then the second output is an encrypted blob file which has the underlying bits. And so this file will end up in a folder that is going to be noted to be expiring. As I mentioned, these start out their life as a expiring file. So let's see that in action. So let me remove this little guy here, and what I'll do is I'll jump back to my database, and actually let's see here, how can I do this? So if I go ahead and I pop open my developer console, I'm gonna actually make this big here. So I'll bring up my network tab, and this is the best way to see what the actual file is that we ultimately upload. So let's make another smiley face here. Okay, so you can see we posted the file to this REST API, and the response had a bunch of stuff, and it gave us an access token, a promotion token, and it also gave us the file ID. And the file ID is the critical element that we need. And so basically, if we go down to my disk, let's see if my thing came up here. No iPad. Okay, so if we go to my disk, the files are, the way Reticulum works is the files are actually stored on the disk. So we don't use anything, say, like S3 or anything like that. We actually wrote Reticulum to just assume the local file system is the place to stick the files. And so when I'm running things on my local computer, they end up just going into this storage folder. And so it's a little hard to see, but the file ID right here it begins with a C7DC, okay? So now if I go to my storage folder, you can see that there's two subfolders. There's the expiring folder and the owned folder. And the expiring folder is where the files start their life as expiring files. And so I go in here, you can see that now I have these additional directories, and these are just the first couple characters of our file ID, which, if you recall, is C7DC. So if I go into C7, and then in here you'll see there's now a DC, certainly, and now here we go. So now we have this is the actual underlying storage for this smiley image. It's the blob file, which is an encrypted blob of the actual image, and then there's this meta file, which, as I mentioned, has the relevant information about the content. So you can see it has the content type is an image, the size, and then this promotion token. So that kind of shows you how files begin their life. They end up an expiring file on the disk in this expiring folder, and they're stored in this nested folder that has their ID. And so if I go back to my storage code, now, sorry, what was I gonna say? So now that's where the file begins. And so now the question is, how does it ultimately become removed? And so, as I mentioned, we clean out all the files that are in the expiring folder every 72 hours, or that are at least 72 hours old. And that's for privacy reasons. So like if I upload this little face here, and then I leave my computer, the networking object goes away, as we saw, like, because it's just never stored in the pinned objects or the room objects to the database table. But however, the underlying file does not automatically get removed immediately, because that would just be very, very difficult to do. What we do instead is we sweep through those files and clean them up periodically. And so the way that works is we have a cron for that. Just see what that is here. And so in our let me see here, vacuum. Just bear with me. So if I look for references to vacuum, I can find they're in prod exx. So this is like, we have a routine called vacuum, that we typically use as the name for the routines that are going to regularly sweep up stuff like this. And so this is actually built into Reticulum. So Reticulum runs a Elixir process that runs cron jobs, basically. Like those are periodic jobs that run on some fixed frequency at specific times of the day. And so you can see we have this one right here, which is storage vacuum. And this occurs at 10 o'clock UST. That's what this cron tab format is indicating. And so that's happening once a day. And I believe that works out to be some early hour in the morning Pacific time. And so if I go back to storage, you can see there's this vacuum routine. And so this function will be called by every Reticulum server at that time. And so the goal of this function is to go through and remove those files that are now out of date, that are in that expiring folder. And so you can see that's basically what it does. It goes ahead, it actually takes a lock, because we only want one server to do this at a time. So we have a whole mechanism we can use to take an atomic lock to isolate this, so only one server is running this code at a time. And then it goes ahead and walks the directories and determines how old the file is. And then if the file is older than the specified time for it to expire, then it will just remove it. And so, this usually runs fairly quickly. And then it goes ahead and cleans up any empty directories. So if you recall, these are in nested directories with their ID. If I go back, so you can see right here, my working directory has them under these nested folders. And so just as a convenience, so that we don't have this huge mess of empty folders, we go ahead and remove all the empty ones. So it's a little bit of a roundabout routine walking down the tree of directories, but this ultimately is what it does. So by the time the vacuum is run, all the old expired files are gone. Okay, so that's a whole picture about how the first phase of file ownership, file lifecycle works with our backend storage system. But we still haven't gotten to the real problem with regards to this bug. So let me go ahead and just I'll reproduce the bug, and so you can see the problem. So this might be a little bit tricky for me to do, so it might take me a few tries. So let's go ahead, and now the key thing that I discovered with this problem is that, Pharaoh Bob asked a question, is there a reason we're not shelling out? And so that's a good question. So the question is there a reason we're not shelling out to say a bash interpreter or something like that to do the removal of these files? And so generally speaking, we're running code that's Elixir, and so Elixir runs inside of what's called the Beam VM. And so the Beam VM is a virtual machine that runs on the server, and there's a lot to be said about it, but one of the things that it does do, which is quite awesome, is that it basically ensures that any code you're running will make continual progress. So for example, so the whole Beam VM was created by the telecommunications industry. And so one of the goals is if you're running software to manage phone calls, what you can't have happen is that if a single bug shows up somewhere on one person's phone call in the software that's running and managing that phone call, you wouldn't want that to affect everybody else's phone calls. You kind of want that person to go down in flames, but you don't want everyone else to get sucked down the black hole with them. And so what the Beam VM does is it provides these guarantees that if you were to run a process on the Beam VM, if something were to go wrong, say for example, it were to get stuck in an infinite loop, or it were to just stall because of some kind of high intensity CPU operation, the Beam VM actually provides very good guarantees that that will not slow down up to a certain point the other processes